Hey, it's Mr. E here, and our aim for today is how do we apply the angle sum and difference formulas for trigonometric functions. So here are sum and difference formulas. Definitely familiarize yourself with them. You don't have to worry about memorizing them because these formulas are provided for you for any exam of mine, and they're also provided for you on the day of the Regents. Okay, so here's our first example. Express as a single fraction the exact value of the sine of 75. All right, so look, sine of 75 can be expressed as sine 45 plus sine 30 because 45 plus 30 is going to give you 75. So since I can express sine 75 in this as a sum of sine 45 and sine 30, I can use the sum formula to find the exact value of 75 by writing it like this: sine 45 plus 30. Okay? So this is the formula I'm going to use. It's a sum formula, and I'm going to make the 45 my A, and I'm going to make the 30 my B. Does it matter which one you make your A or B? No, in reality it doesn't matter. Just make sure that you are consistent throughout the whole problem with what you started with. So if I'm going to make 45A, I have to use that throughout the whole problem. All right, so let's go ahead and substitute now. So it says the sine of A times the cosine of B plus the cosine of A times the sine of B. What's the sine of A? Well, the sine of A is the sine of 45 degrees. The sine of 45 degrees is radical 2 over 2. Remember, you can get that from your chart. Sine of 45 degrees is radical 2 over 2. What's the cosine of B? The cosine of B is the cosine of 30 degrees. That's radical 3 over 2. What's the cosine of A? The cosine of A is radical 2 over 2. Now we need the sine of B. That's 1 over 2. Sine of B is the sine of 30 degrees. The sine of 30 degrees is 1 over 2. Okay, now let's go ahead and substitute. We get this. Sine of A over here goes there. Cosine of B is over here, goes there. And so on and so forth with the other ones. When you substitute into the formula, these values do not write sine anymore because this value represents the sine of A. So you drop that. Now we just have to work it out. Radical 2 times radical 3. Remember, when you multiply fractions, you're multiplying this way. So radical 2 times radical 3 is radical 6. 2 times 2 is 4. So we get radical 6 over 4 when we multiply these two fractions here. Radical 2 times 1, that's radical 2. 2 times 2 is 4. Now we can express this as a single fraction this way. Keep in mind that these are not like terms. Radical 6 plus radical 2 is not radical 8. So do not combine them. Keep them separate like this. So here is our answer. Just to give you a little heads up, there is another way to express this answer, and let me expose you to that now because it might show up like that later on. We can factor out a radical 2 in the numerator, and we can say radical 2 times radical 3 plus 1 instead of saying radical 6 plus radical 2. Why is that? Well, because we factored out a radical 2 times radical 3, that's radical 6, and then radical 2 times 1, that's radical 2. So we can express the answer in this way as well. So it's another way of saying the same thing, and you should be familiar with both ways. Example 2. when the sine of x equals -8/17 and x lies in quadrant 3, and the cosine of y equals -4/5 and y lies in quadrant 2, what is the cosine of x minus y? So here we're going to be using a difference formula because we have a subtraction here. And instead of using the letters a and b, I'm going to use the letters x and y. X for a and y for b. Just because that's what the problem is using. Okay, so now, for me to substitute into this formula, I need to know what the cosine of x is. I need to know what the cosine of y is. I need to know the sine of x, and I need to know the sine of y. From the problem, I know the sine of x is -8/17. And I know that the cosine of y is -4/5. So those were given to me, okay? They were given to me here. I didn't need to go in my chart to find them. The only problem is I don't know what the sine of y is, nor the cosine of x, and I need to know those values in order to substitute into the formula. So how do I find the values sine of y and cosine of x? Here's how I do it. I know that x lies in quadrant 3. That's what I know. I know x lies in quadrant 3, so here's quadrant 3 and here's x. X is a reference angle, and it's in quadrant 3. And I know that the sine of x is -8/17. So what that's really telling me there is that the opposite side is -8, and the hypotenuse is 17. That's what that's telling me. Is that clear? So the opposite is -8 and the hypotenuse is 17. Why is that? Well, because go back. Remember SOHCAHTOA? Remember that? Sine is opposite over hypotenuse. So let me rewrite this x. That doesn't even look like an x. There it is. So now, what was the point of that? Well, because since I'm looking for the cosine of x, I can use these two sides to figure out what the missing adjacent side is. Because to find the cosine of x, you need to know what the adjacent and the hypotenuse side is. So let's go ahead and find the adjacent side. How are we going to find it? Well, look closely. Here's a right triangle. I can use Pythagorean Theorem to find this missing side. Pythagorean Theorem, a squared plus b squared equals c squared. Yeah, remember that? All right, so it's going to be 8 squared plus b squared equals 17 squared. So that's going to be, let's just -8 squared minus 8 squared. So that's going to be b squared equals 17 squared minus 8 squared. So that's going to be 17 squared is 289. 289 minus 64 is 225. So b squared equals 225. Square root both sides. We get 15 for our adjacent side. So our adjacent side here is 15, which means that the cosine of x is 15/17. Now we have to figure out what the sine of y is. So here's what we know about y. We know that y is in the second quadrant, so it's going to be here. Let's see. And it's the reference angle, of course. And we know that the sine of x is -8. Excuse me, sorry, I was looking at the wrong one. We know that the cosine of y is -4/5, so that's the adjacent over the hypotenuse. So that's -4 over here. I'm going to use blue for this triangle here. So that's -4 for this side, the adjacent side, and 5 for the hypotenuse. So what's this missing side over here? Well, you can use Pythagorean Theorem, but I'll save you the suspense. It's 3 because it's a 3, 4, 5 right triangle. So what's the sine of y? Sine of y is going to be opposite over hypotenuse. So the opposite is 3, hypotenuse is 5. So the sine of y is going to be 3/5. That's the opposite over the hypotenuse. Okay, so now we can substitute. Cosine of x is 15/17 times the cosine of y. That's going to be -4/5 times the sine of x. The sine of x is going to be -8/17 times the sine of y. The sine of y is going to be 3/5. Okay, let me just pause here 1 second to point something out. This 15/17 should be negative. And let me explain to you why, and then I'll explain to you why I did it just now at the end. It should be negative because cosine in the third quadrant is negative. Is that clear? Cosine in the third quadrant is negative. Now, the reason why I waited till now to show you that is because students tend to forget that. And this is a nice way to remind you of that, sort of like a little rude awakening. So the cosine of x is -15/17 because x is in the third quadrant, and in the third quadrant, cosine is negative. Okay, that's why you'll notice here that the sine of y is positive because y is in the second quadrant where sine is positive. And that's why you'll also notice that the cosine of y is negative because y is in the third quadrant, like we said earlier. Okay, so let's just go ahead and multiply this out. So this is going to be 60/85 plus -24/85. And that's going to give us 36/85. That's our final answer. Okay, now it's your turn to try it. Find the exact value of the sine of 105. And I'll give you a hint. You are going to be using a sum formula.